right, we're going to discuss vocabulary that directly relates to quadratic functions. So our focus right now, this unit we're moving into, is quadratics. So we're going to look at these vocabulary words in relation to quadratic functions. So let's start off with what is a quadratic function. So here's my first vocabulary word. It's quadratic functions. A quadratic function has 2 as its highest exponent. So the variable is going to be squared, okay? So for example, the standard form right here is going to be f of x equals ax squared plus bx plus c. Notice that highest exponent is 2. That's how you know this is quadratic. So if we look at an equation and it only has x to the first power, not x squared, that's going to be linear. But if we look at an equation that has a variable squared, that is going to tell us that that is a quadratic function. So if you're basing your work off of the equations, a quadratic equation is going to have a variable squared, whereas a linear equation is not. It's only going to have the variable to the first power. It's important to note that a can never be 0, because if it was 0, 0 times x squared gives me 0, and then I wouldn't have an x squared anymore, so it would no longer be quadratic. And a, b, and c are real numbers. So quadratic functions have an exponent of 2. The highest exponent is 2. Okay? The next word we have is a parabola. The parabola is the shape that comes from a quadratic function. So if I graph a quadratic function, its graph will be a parabola. Don't be scared to say this word. People are always unsure. It's parabola. Parabola, not parabola. Parabola, okay? Parabola is this horseshoe shape, all right? So the parabola is the shape of a graphed quadratic function. Oh, I can't get them to part. The next vocabulary word is the parent function. We know with linearity, our parent function was our most basic function. It was just f of x equals x, and it was that straight line that went right through the origin. Y-intercept was 0. It was very basic, okay? Same thing with quadratics. It's the most basic function in the family, okay? The parent function is the most basic function in the family. A quadratic parent function is f of x equals x squared, or you can write that as y equals x squared. It's going to come out looking like this parabola that opens upward, that has the point at 0, 0 is its vertex, okay, and its y-intercept and its x-intercept. So it's the most basic function. You're going to want to write down this equation, f of x or y equals x squared. You can always type that straight into your calculator and look at it. It will give you specific points. If you need to graph the parent function, type into your calculator y equals x squared, go second graph, and you'll see a table of all the points, and you can choose some points to plot to draw your parent function, okay? You need to have the parent function memorized because questions can ask you, you know, how does this quadratic compare to the parent function? If you don't know what the parent function is, that's going to be a very hard question to answer. So the parent function is y equals x squared, the most basic function in the family, okay? Our next vocabulary word is the x-intercept. We're going to run through this real quick because this is definitely a review. It's the coordinate where the graph crosses the x-axis. And we know that at the x-intercept, y is always 0. So with a linear function, it would just be right where it crosses the x-axis. With a quadratic function, same thing. Right where it crosses the x-axis. And you can see with quadratic functions, there can be more than one 0, or x-intercept. I called it a 0. That's another word for it. We're going to get there. X-intercepts can be called zeros. They can be called roots. It's important that you know that vocabulary because they may ask you in a different way, you know, what is the 0? You need to know the zeros are the x-intercepts for any kind of function, okay? We know that y is always 0 at the x-intercept. And the opposite is true at the y-intercept. We know x is always 0 at the y-intercept because the y-intercept is the point where the graph crosses the y-axis, okay? So we can see with this parabola, its y-intercept is here, the point where the graph crosses the y-axis. X would be 0. So if I wanted to write that as a point, that would be like 0, -1. Let's say that's at -1. 0, -1 would be the point where the y-intercept is. Our next one is the vertex of a parabola. The vertex of a parabola is going to be the maximum or the minimum point on the graph, okay? So where it crosses the axis of symmetry, which is going to be another one of our vocabulary words. Our axis of symmetry is going to cut our parabola in half, and the lowest minimum or highest maximum point where the line begins to change directions, that is going to be your vertex. The vertex is a point, so if you're asked to give a vertex, it must be in the form, we call it HK, same as XY, it's the X value, Y value. So for example, if we wanted to look at this maximum, let's say we were going to label this on a graph. So maybe you would write that this is the vertex, maximum, and then it would be the point, let's say that's over 2 up 3. So 2, 3 is the maximum, which is also known as the vertex, okay? And that I used a lot of the upcoming vocabulary in that explanation. The axis of symmetry is this dotted line right here. It's a line that passes through the vertex and cuts it right in half. It's going to make it symmetrical. Axis of symmetry, it's a pretty, you know, kind of obvious verbiage that's used to describe it. The line that cuts right through the middle and cuts it in half. We're going to learn later that you can find the axis of symmetry using the formula negative b over 2a, but don't worry about that for right now. You may have that jotted down, but we will get to that later. The axis of symmetry is a line. So when you describe the axis of symmetry, it has an equation. It's not just a number or just a point. It's a line, okay? So for this example, let's say this is crossing at where x is -2. This is a vertical line. If you remember, for vertical lines, we ask ourselves, which axis does it cross and where does it cross that axis? Well, it's crossing the x-axis at -2. So if I needed to label this, I would call this the axis of symmetry, and I would write x equals -2. Not just -2. It's the line, the vertical line, that has the definite equation of x equals -2. Very important. Okay, axis of symmetry as a line has to be written as a line. Okay? Then the next one is the maximum value. If a parabola opens downward, as this one does, then its vertex is going to be a maximum, which is the highest point. Point of the graph where the y value is the greatest. The minimum, oops, one too many. The minimum is going to be just the opposite and pretty self-explanatory as well. The minimum is going to be the lowest, where the y value is the smallest. And it is the vertex, okay? And it's going to be on parabolas that open upward. So if the parabola opens upward, it's going to have a minimum value. That's going to be its vertex. Extrema, I didn't have you define this one, but I just wanted you to know that you may see these referred to as extrema. Anytime there's a maximum or a minimum, that's called an extrema on the graph, okay? And we've talked about this a little bit. The zeros, anytime you have an x-intercept, that's where y equals 0. That is your, those are referred to as zeros, okay? Zeros. Zeros are the same as x-intercepts and also can be called roots, all right? Very important that you understand that all three of those words would be asking for the same thing, the point where the line crosses the x-axis.